Alright, Unit 7, number 2. In this section we will learn two strategies for simplifying square roots of numbers that are not perfect squares. Both strategies are really doing the same thing, but the methods look a little bit different, so you get to choose based on preference. Think back to the previous lesson. What does it mean to simplify a square root of a non-perfect square? Back on that last section that we did, right, you could we either had two sets of the square root of 2 from those line segments, or you could have had the square root of 8. But we talked a little bit about this last time. This is the answer that we really want,
on the test,
which is called the simplified form of this square root of 8. So what was the difference between the simplified version of these square roots as opposed to how they looked before they were simplified? Like this one, 8 square root of 8 equals 2 times the square root of 2. Square root of 18 equals 3 times the square root of 2. It tells us how many square roots of something that we have. Like 4 square roots of 2 or 2 square roots of 10. Alright, what observations can you make about the simplified versions of these square roots, not perfect squares? List them here. We did kind of explain these. It's kind of like breaking these up into a certain amount of square roots of 2 or square roots of 10. And again, we saw that on the graphs with these. So if I had these 4 dots and then I connect them this way, and then I have more dots like these, and this one was the square root of 2, but if I extended this line, then I have another square root of 2, which is why we would have 2 square roots of 2, like this, okay? So this should be the major observation, is that we can take the square root of 8, which is what this would have been with the square. That's the area. But we can break this up into separate parts as well. That was all explanation. This is where we get into actual stratagem. Find the greatest perfect square that is a factory. This is the first thing that we would do. Find the greatest perfect square that is a factor of the number inside the square root symbol. Rewrite the number inside the square root symbol as the product of the greatest perfect square and the other factor. Then we take the square root of that perfect square, and then that really is just a number outside of the square root now. And then we'll keep doing this process until we can find no perfect squares. That's okay. So we kind of intend for that to make no sense because we haven't done it yet. But hopefully this will help us figure out how to do these. So let's take, they gave us 3 examples down yonder, but let's look at this a little bit differently, so we'll make up our own example. So what numbers do you guys want? Let's take the square root of...
Can we do 3?
Good idea. So let's start with a perfect square and see what this means. Okay. So a perfect square, let's take something like 900. Okay. This is a perfect square, but using this strategy, it says find the greatest perfect square that is a factor of this number. So this one actually has 2 because it's a perfect square. So that would be 9 and then 100. Both of these are perfect squares. See, and then it's saying that we need to take the square root of both of these, the square root of 9, and multiply it by the square root of 100 because these both are perfect squares.
Wait a minute, but the square
And then the square root of 9 is 3, and the square root of 100 is 10. So the actual answer ends up just being 3 times 10, which is 30. Now some of you guys didn't need all those steps for this, but it may be helpful for non-perfect squares like 8, 40, and 32, the examples here. So let's go ahead and make up our own example on these, and then we'll do that. And what number should we use? Let's use the square root of 75. Alright, so what I'm looking for is a factor of 75 that is a perfect square. Alright, so I could break this up and make factor pairs on this. So 1 times 75, none of those are perfect squares. What about 3 and 25? 3 and 25, there we go. Well, 25 is a perfect square, so I can break this up into the square root of, I'm going to make it 25 times 3, just so the order makes a little bit more sense on this. Well, 25 is a perfect square, so I can break this up into the square root of 25 times the square root of 3. And the square root of 25 is 5.
Whoa, what's the square
Because
root?
5 times 5 is 25. So, we could look at this chart here, right? Square root of 25 is 5. Square root of 25 is 5. And somewhere over there, square root of 25 is 5.
Oh, you had it on it for a second.
So that one is 5 times the square root of 3 is the final answer for the simplified square root on this one. So this is already 5 times the square root of 3. We just didn't show the multiplication. So, but you can if you want on that.
That's like the first one.
Strategy 2, using the factor tree method, which we love. Find the number inside the square root symbol. Look for and circle as many pairs. And this is only for square roots. We need pairs, okay? And then we put a circle around any numbers that are not a pair. Not part of a pair, whatever. Rewrite the numbers as factors to see that the pairs can be removed. Remove the pairs to leave any leftover numbers inside, and then we will multiply everything that we took out on this. Some people like this method, some people don't, and you get to choose, which is the great thing about math. Alright, so we gave you guys a couple examples right here. And you can see the hint, you can stop when you find a pair rather than continue to factor it down, whatever. Alright, so let's find our own on these. And this is how this would work for a perfect square. So let's use a perfect square first, such as the square root of 144. Okay. So it says we need to use a factor tree on these. And we're going to use prime factorization. So for example, I know that I could do 2 times 72. Yeah, so you could have used 12 and 12 if you wanted to. 2 is prime. So then I'm going to factor this out even further. And that would be 2 and 36. And then 36 is 9er and 4. Neither of which are prime, so we'll just keep factoring 3 and 3. And then we got 4, which is 2 and 2. So our prime factorization is 2, 2, 3, 3, and 2, 2. So this is really the square root of 2 times 2 times 3 times 3 times 2 times 2.
I really hate this method.
That's okay. It may make sense later. That's okay. Whatever you choose. But I'm going to show you this either way. So I'm going to look for pairs of numbers. I got a pair of 2s, pair of 3s, and this pair of 2s. That means that those are perfect squares. So I can just take out a 2, a 3, and a 2 and multiply these. And 2 times 3 times 2 is 12. Now we already knew that the square root of 144 is 12 because it's a perfect square. And this kind of verifies that.
We do like 6.
And this is part of the last section that we did. Is 144 would be the area of the square. And we would be asking ourselves, what is the side length of that square? 12. Yeah, that's what a square root is. It's asking what the side length is of a square with this area, 144.
So why would we?
Alright, so let's look at that example that we'd already done, the square root of 75, right? So if I were to factor this out, I would say, I know I could do it with 5, but that would be 15. And 5 is prime, so I can break 15 up into 3 and 5, both of which are prime. So this is really the square root of 5 times 3 times 5. Now just for the sake of convenience, I'm going to move the 3 and the 5 closer to each other. So this is now a 5 and that's a 3. And right here, I can see I got a pair of 5s, which now makes this, because it's a perfect square, a 5. And then this square root of 3, this 3 right here, does not have any pairs to pair it with, so it's just a square root of 3. And that, of course, is what we got on the last one.
Oh, okay.
Some of you guys' calculators will do this for you, but that's not going to work on a test. You still got to show some work on the test there.
Yay!
And since we have 2 strategies right now, when we look at these examples, you guys got to tell me which strategy you like. You like 1 or 2?
1!
1.
My
Okay.
teacher, 1!
And we can switch off, so we can do them differently, all right? So using stratagem 1, I'm going to break up, I'm going to look at factors of 50, but I want a perfect square on that, right? So 1 would be 25 and 2. 25 times 2. And 25 is the perfect square on these. So this really ends up being the square root of 25 times 2.
Oh, that's pretty darn easy.
Which again, I can break this up into the square root of 25 times the square root of 2. And the square root of 25 is a perfect square.
Which is 5.
5. The square root of 2 is not a perfect square, so it just stays square root of 2.
Oh, I get it more.
There we go.
I think I can see your work.
If you did this just with the numbers switched, you can write the square root of 2 times 5. It just kind of looks like you mean the square root of 25.
49.
So be very careful with how you write that. We want that 5 to be in front of the square root so we can differentiate between the two. For method 1, you kind of have to know a lot of the perfect squares. And you got to know that there would be factors of these numbers. Like 50, 25 is a factor, or it means that if I break this up into multiples, 25 times 2 would give me 50. But I have to know that 25 is a perfect square to figure that part out. Alright, so 128, this is method 2. So we're going to break this up.
Can I make up my own?
Now you can find a factor of 2, but you don't necessarily need to. Some of us can see that 4 will go into this thing 32 times.
Yep.
Oh,
That's what I
whoa.
did. Yep.
And 4 can break up into 2 and 2, which are both prime.
Shut up.
32 can break up into 8 and 4. And 4 breaks up into 2 and 2 already. But 8 can break up into 2 and 4. And 4 can break up into 2 and 2. So as it turns out, we just have a bunch of 2's being multiplied onto these. It's the square root of 1, 2, 3, 4, 5, 6, 7 2's. And now we're just looking for pairs on this. So here's a pair of 2's, here's a pair of 2's, and another pair of 2's. So I can see that these would be perfect squares with the side length of 2. So these are all multiplied together as well. And then I'm going to multiply this by the square root of this last 2, which had no pairs. Now I'm just multiplying these 2's. So 2 times 2 times 2 is 8. And then we still have this other square root of 2 radicand. And that right there is my final answer. Alright, now it's important on these ones because, yeah, we didn't see any like these, but we can multiply the 10 by that square root. Multiplication's great because we're just combining
So
this stuff.
with 960.
So really we're just looking for factors of 96. We're going to keep that 10 there because it means that we've already simplified this a little bit. So in other words, this could be an answer from a previous one where you could have taken this and simplified it a little bit, but it means we need to simplify it even further, okay? So using method 2 means I'm going to split 96 up. I can see 3 goes into it, looks like 32 times.
Holy cow.
Now we've done 32 as well.
Because he's a wizard.
Well, 9 and 6 are both divisible by 3. Okay.
He's Albert.
I don't remember a lot of fat wizards, but whatever.
Wizard Harry.
Alright, so I've got 8 and 4 on this one. Some of you guys would use 16 and 2. 4 splits up into 2 and 2. 8 splits up into 2 and 4. And then 4 splits up again into 2 and 2. So right there, all the circled numbers are the factors. And we can see that there's already not any pairs with the 3. So when we write this out, we can't forget the 10.
So it would be 10 times 3.
Then we got the square root of all those numbers. 3 times 5 2's. 3, 4, 5 2's. Alright. So on at these, I'm just looking for pairs of numbers. There's a pair of 2's and there's a pair of 2's. And that means that I can take these out as a 2 times a 2. But I can't forget that I've got that 10 right account. Now in this square root, I'm just going to write all the numbers that didn't have pairs, like this 3 and this 2. So they stay inside. 3 times 2. So this is expanded. What I want to do is now simplify these. So I've got 10 times 2 times 2, which is 40, times the square root of 3 times 2, which is 6.
Oh,
Bam.
no, but that's not simplified enough.
No, it is. All right, good luck.
Okay. So I broke it down to 2 and 100.
Who's doing this?
I am.
Oh, hey, you copied me.
And
10.
wait, 2
No.
and 50. What?
You're 10 and 10.
No. And then break this down into 25 and 2. And then 25 is broken down to 5 and 5.
Man, I admit, Spaghetti 2 is
You
way
did
easier.
it wrong.
I didn't do it wrong. And then 5 times 2
Yes, you did actually.
is 2 times 2. And I can't remember what to do from there.
All right. Thank you.
Who did that?
Great.
Are you just supposed to leave it like that?
No. Yeah, but this is a good place to be because there's only really kind of one more step.
Wrong.
So on at these, we're going to take this pair of 5s, and then we're going to take this pair of 2s and take them out of the square root because they're perfect squares. 5 and 2. And then we've got this other 2 remaining, which is going to stay in the square root.
Compilation of
All
John.
right, so 5 times 2 is 10. And then we've just got the square root of 2 remaining. So that's our final answer there. We can't simplify that square root of 2 any further. So fractions, these ones actually end up being extremely difficult unless you find them to be extremely easy. So what we can do on these, and this is the nice thing about fractions, is we still do have a fraction, but we get to take the square root of the numerator and the square root of the denominator. Now just for the sake of time on this one, we can see that both of these are perfect squares. The square root of 1 is 1. The square root of 4 is 2. So my final answer ends up just being 1/2.
Oh my gosh.
All right, there you go.
Funny joke.
Okay, so I'm going to simplify that. This will just equal 7. This will equal 6. 7 over 6.
Oh, okay. 7/6. That is correct.
Collaborations.
Okay, so 72 can be divided into 2 and 36. And then that can be divided into 2 and 18, which can be divided into 2 and 9, and then that can be divided into 3 and 3. So then you have a pair of 2's here, which will just equal 2 on the outside, and then you have a pair of 3's here, which will equal 3 on the outside, and then 3 times 2 is 6. So I forgot. Well, yeah, I'm about to get that. And then 6 square times the square root of 2.
Bam. That was excellent.
Mind blown.
Good job, Austin. I'm proud.
Now we got this negative square root stuff. Now this one's good because really we can show a phantom 1 right there. Kind of like the 10. So it's just negative 1 times whatever we can pull out of this square root of 8 stuff. So 8, we can, using method 1, this would be 4 and 2. And 4 is a perfect square. So we can rewrite this as negative 1 times the square root of 4 and 2. Now this is method 1, so I didn't use all the prime factorization. And then we can rewrite that as the square root of 4 times the square root of 2 times the square, negative 1 rather. And then we'd have negative 1 and the square root of 4 is 2. So multiply that and then multiply this by the square root of 2. And negative 1 times 2 is negative 2
Yeah, Mr. Sal, I'll make you a
times the square root of 2.
We get out at 11:27, right?
Alright, this one's a nice one because square root of 36 is a perfect square. So the square root of 36 is just 6. And then we'll bring this negative down here as well. Negative 6, done. Good luck.
Okay.
Go, Gavin.
So I do.
Like and subscribe.
So I do this second one.
the second strategy, I guess. So you can break this up into 3 and 49, and 3's prime, and then 7 times 7 is 49. Those are both prime, and then and then when you have so you bring this down because this is a pair, so that'd be 7, and then 3. Shoot, like that.
Good job.
Right? Okay.
Good job.
That means.
Wait.
Now hold on this one. Hold on. So on this one,
It's the other way around.
yeah, it's the other way around there. So the 7 comes out of the square
Oh,
root.
my papers.
That's okay.
I don't even know why. I didn't even.
It's all right. Don't worry. So this 7 gets pulled out. This 3 is going to stay in the square root. That's the only difference on that. Good luck.
Okay, thank you. Okay, I need to look at my paper. Okay, so got 9 and 5, and then
Guys, we gotta listen.
shoot. Okay, and then got 3, and this is a pair. And so that'll be that. And if you times -5 and 5, it equals -25. Is that right?
Incorrect.
Close.
Mr. South.
Now the factorization is actually very good on these.
Oh. Yeah, I just.
So let's look at this. Right, the 5 came from the 45 right there.
Yeah.
So you're going to take this -5 and move it into the front.
Yeah.
Then you got this pair of 3's, which we're going to multiply by that -5.
Yeah.
And then you got the square root of the 5 up account, which had no other pairs with it. Now this -5 can't be paired with it because it's not in the square root.
Yeah.
So yeah, we got to be careful on that. Yep, that's good. Well, now we can multiply these two.
It's -15.
Yeah, and that'd be -15 times that square root of 5. All right, good luck.
Okay. So, what'd you do? You get 2 times 2, because that's half of 4, and so then you go right here, and then that would be 2, and then you divide this by 5, and then you get 5, and then that is your answer. Boom. Touchdown.
All right, thank you. I worry slightly about the method, but be careful. We're looking for pairs on these, right? Or perfect squares. And 4 is a perfect square, and so is 25.
I know, but I already did it, and there was none, so.
That's okay.
I was just too late.
Good luck.
Thank you. Okay. So first thing we do is we separate these two things. We go square root of 27. Boom. It's boom. And then we go square root of 81. We simplify these down. You can't simplify their square root.
I like how you're looking at me.
Yeah. And then, so 81 is 9. It equals 9.
Yeah.
But then we have to simplify 27. So we have to go. We have to split it.
3 and 9.
Yeah.
No, it's
No.
3.
Yeah.
3 and 9.
3 and 9. Yeah.
No, 9 and 3.
There. So we got these. Then we just multiply this. Whatever that is. We pair this up. This goes 3 outside of 23 out of 3. So then we go 3. And you can circle that with pride on your test. Boom.
Rick, say one thing only. Just one. Now this one, I didn't mean for it to catch you off guard on that, but it's okay that it did. Because 3 and 9 can also be simplified. So we can simplify the 3 and the 9 into this 3, leaving us with the square root of 3 over 3. All right, so for the sake of the class, This is Mr. Sal signing out. Like, subscribe, comment below. Let us know what you think.
It's a trap.
And go check out my other videos. What the heck?